Assalamualaikum and hi everyone. Nernst equation part 2. For the second part of Nernst equation, you are going to learn how to use Nernst equation to determine cell potential EMF and determine the concentration of partial pressure of a species. So consider the second example here. So an electrochemical cell is represented as, so this is the cell notation, okay? Right, so if the value of the cell potential is 1.198 watt, determine the concentration of the H plus solution. So we want to find out what is the concentration of the H plus solution. So first of all, you have to find out what is the reduction and what is the oxidation reaction. So from this notation, we notice that at the left side is referred to the anode half cell. So this is referred to the oxidation reaction. As for the right hand side, this is referred to the cathode. So this is the half cell for the cathode. So for the reduction, which refer to the cathode is Ag plus aqueous react with electron and produce Ag solid. As for the oxidation, so oxidation is referred to the anode. So H2 gas produce H plus aqueous plus electron. So since oxidation equation is not balanced, so you have to times 2 to balance. Since the oxidation reaction needs 2 electrons and for the reduction is only 1, so for the whole equation reduction you have to times 2. Right, next step, you can cancel out the number of electrons for both sides and finally you get the overall equation. So we have to find out the overall equation in order for easier to you to write the Q expression. So now, so you have to calculate the E naught cell. So E naught cell is equal to E naught cathode minus E naught anode. So you will get E naught cell is equal to positive 0.80 watt. Remember, the positive sign you have to include, okay, in your calculation. From this overall equation, we notice that the number of electron transfer is equal to 2. And this is the function why you have to write the overall equation in order easier for you to write the Q expression, okay, reaction quotient Q. So this is the reaction quotient Q. Alright, so remember concentration of the product divided by concentration of the reactant. Since the H plus ion have coefficient 2, so it should be power of 2. Same thing goes to the Ag plus, also have coefficient 2, concentration Ag plus power of 2. Since hydrogen is in gas phase, you can write partial pressure of H2 like this. Right, so next write the Nernst equation. Okay, this is the Nernst equation. And you have to substitute the Q. You cannot write generally log Q. So you have to define Q. What is Q? Right, let's substitute all the values here. And finally, you get the concentration of H plus ion is 1.9 times 10 power of negative 7 molar. Alright, so now we move to the example number 3. Okay, consider a voltage cell in which the reaction is. So this is the overall equation. So it is found that the voltage is positive 0.560 volts when concentration of Zn2 plus is 1.0 molar and the concentration of H plus is equal to 4.184 times 10 power negative 4 molar. Calculate the partial pressure of the hydrogen gas form. What is the partial pressure of the hydrogen gas form? Given to you the E naught reduction for zinc that is negative 0.76 volt. Alright, so first of all, we have to identify which one is the anode and which one is the cathode. Right, based on the overall equation, we can see that zinc and produce Zn2 plus, there is increasing of oxidation number. So therefore, zinc is undergoes oxidation. So anode is the refer to the zinc electrode. Okay, as for the H plus ion, become H2 gas. So there is decreasing in oxidation number from positive 1 to 0. This is reduction equation and this is referred to the cathode. Cathode is referred to She. So reduction is referred to She and the oxidation is referred to the zinc. Okay, since the half cell reaction for reduction is imbalanced, so you have to balance it first. Okay, after that, okay, you can cancel out the number of electron and you will get this overall equation. So the function that you have to write down the reduction and oxidation reaction here. so that you can notice the number of electron transfer that is equal to n equals to 2. And one more thing, you will know which one is the anode and which one is the cathode. Okay, you can calculate the E naught cell. Okay, E naught cell equals to E naught cathode minus E naught anode. Alright, so for the She, the value of E naught reduction for She is 0. Substitute E naught reduction for the anode. Both value here is equal to the E naught reduction. And finally, you get E naught cell is equals to 40.76 volt. Next, write the Nernst equation. And remember, you have to substitute the value of Q. You cannot write the general log Q. You have to define because overall equation is already given in the question. Alright, so remember for the Q expression is only considered for the aqueous and also gas phase. Okay, so Q would become concentration Zn2 plus time partial pressure of hydrogen gas over concentration of H2 because we have coefficient here 2, now it becomes power of 2. Now, substitute all the values in the Nernst equation and finally you get the partial pressure of hydrogen gas is equals to 1.0 atm. Okay, so remember you have to write the final answer with the correct unit.